we will have a tutorial this week. I'm imagining that some of these maybe cause a problem, so we can look at all of that in the tutorial, okay? So if you had trouble last night, that's fine. Just mark the question for the tutorial we'll do later this week. Page 12. What? Okay. So, remember this, no, it's only Monday. No, it's Tuesday. Yes. Keep thinking it's Monday. This Tuesday, isn't it?
Yeah.
No, don't get my hopes up. Yeah. Last week. Okay. What happened to you? Right. Last week we saw mean. Or was that this week? It was yesterday. Right. Yesterday we saw mean, median, and mode. Remo, come on. Yesterday we saw mean, median, and mode, and midpoint. So do you remember what the median is? It's the middle value. Okay. So we're going to continue with that idea a little bit. Okay, so I think we'll just have some numbers as an example to explain the idea. I think will be better. So I'll go with 10 numbers as example 1. So we'll say 5, 4, 3, 7, 8, 9, 0, 1, 0, 2, 0. Okay, so can you write these numbers down, please, as an example? I'll make the font a bit larger too. So much talking. Come on, write this down. You got the numbers? So what I want you to do first is get the median for me. So I want the median here. Five, 4, 3, 7, 8, 9, 1, 0, 2, 0. Okay. 3.5, is it? Yeah. So what we need to do is first we need to write the numbers out, but we need to sort them from smallest to biggest, or biggest to smallest. So, if I have 10 numbers, the middle will be at the 5th and the 6th. 1, 2, 3, 4, 5, 6. So here's the middle here. I'll highlight it. So it would be equal to 3 plus 4 divided by 2. So the median is 3.5. Okay, so let me just undo that bit. So we have a similar idea for something called the lower quartile. So the lower quartile is like the median, except for the lower half. So I'll explain with some colours here. Here are the 1, 2, 3, 4, 5 small numbers in yellow. And then here are the 5 bigger numbers in orangey, browny colour. Right, so the median, where's the median here? In the middle, 3.5. Yep. The lower quartile is the middle, the median of this half. So what's the middle number here?
1.
It's 1. So this is called the lower quartile. And here This one, what do you think it's called? Higher quartile? Not quite. Almost. Upper quartile. Although higher quartile I think is okay as well. So the lower quartile is at the 25th percent mark, and then here this is at the 75th percent mark, and then the median is at 50%, which is going to be, I'll put in a different color here, or maybe not, I'll put in bold. Yeah. Okay, so can you just write this example down? I mean, add in lower quartile and upper quartile. Yeah. Does anybody remember from last time what the range is equal to? Yeah, very good, which is 9 minus 0. Yes? There is something called, I'll write it up the top here, range equals 9. Need more space. There's something called the interquartile range. And all that is the upper minus the lower. So in this example, what would that be? It would be 7 minus 1, which here would be 6. So the interquartile range is the upper minus the lower.
What is it for? What's it used for?
The use is used with the median. So what you can say with the that half the data is within 6, is within a space of 6 around the median. So if you were to picture this here, if I draw it, what was the median? 3.5, wasn't it? And the lower quartile? And the upper? 7. So what you're saying, Malik, is if imagine this was people's, I don't know, if it was something like income, you know, like 3.5 would be maybe say like 35,000, whatever. What you're saying is that 50% of the data is within a space that's 6 wide. Like it's like saying that half the people can fit within a space that's only 6 units wide. So in fact, the interquartile range is a lot like the standard deviation. It won't be exactly the same thing, but it's a similar idea. Well, actually, sorry, that's not true. It should be interquartile range divided by 2, because the interquartile range is the total. Anyways, you don't need that part. So if I go back to my data here. So interquartile range is 6 then. Okay. Now, let's look at another example. This example is actually quite easy because there's an even number. 10 is 5 and 5, so it's even. But then it gets a little bit more complicated if there's an odd number like 11. So let's have a look at that. Can I delete all of this? Yep. Okay, so example 2. So let's put in 11 numbers. 5, 2, 1, 1, 0, 7, 4, 2 again, 3, 8, Right, so example 2. Okay, so write this one down, please. You got this? Yeah. So now again, I want you to get me the median. Because there are 11 numbers, where will the median be? Of the 6th number, so it's just one number to use. You have them sorted? Yep. Right, so let's sort these. Sorted. Data sort from let's do it the other way this time. Right, so this is the data sorted. So the median, let's see, if we start down the bottom here, 1st, 2nd, 3rd, 4th, 5th, 6th. So this is the median here. Okay, so let me just make this a tiny bit smaller. Okay, so this one here is equal to the median. Now, I want you to try and tell me the upper quartile here. So tell me what the upper quartile is. For the top half, the upper quartile. So I just want one number, the upper quartile. So you went with 5? 4.5. Now you see the problem here. The problem is, do we include the 2 or not when we're making the 2 halves? So you have 2 choices. You can include the 2. So this here would be the upper half, which I'll put in yellow. But then if you include the 2, you have to do so in the lower half as well. So I'll put that in orange. But you see that the 2 gets counted in both halves. So I'll need to put a different colour there. I'll put it in green. There's more. Actually, no, let's fix that. Yellowy green. Oh yeah, I can do yellow and I can do green, and then in the middle can be yellowy green. Brilliant. And then here. Oh yeah. Can you see it?
Yeah.
Hang on, I need a lighter green. Can I go for a turquoise? Okay, we'll have to grey. Okay. Right. So you have actually 3 methods you can use here. So I think Victor, you said 4.5, and then Remo, you said 5. Now it's not like those answers are right or wrong. Like both are fine. The exam, they won't usually the exam won't tell you which method to use. So you just need to say which method you're using, and that's fine. So the first method I'll use, we'll use the method where we exclude the mean. So this method, I'll write it here. Let me delete that. This method is we exclude the median. So if I don't use the median, and I just have these 5 numbers here, what's the upper quartile? The upper quartile is equal to 5. And by the way, the letter for upper quartile is Q3. That's equal to 5. And then the lower quartile, Q1, the lower quartile would be 1. And here the median, which is Q2 actually, is the letter we use, that's equal to 2. So, if you use this method, please say in your answer you're using the excluding median method. You exclude the median from the 2 halves. Okay, next method, yes?
I have a question. When it's an even number, do not easy.
Well, for an even number you have no problem, because when there's an even number you can nicely split them into half and half. So like if it was 10, you can have 5 and 5, and then there's not really any question. But I suppose, like if you had, let's say something like 1, 2, 2, 3, 1, 2, 3, 4, 5, yeah. So for even numbers, you can nicely split this into 1, 2, 3, 4, 5, and this one here you can split into 5 as well. So there's not really any problem when it's half. Both methods would give you, well, no, both methods wouldn't give you the same answer here. Not in this example. What's the median here? 4. So if I include the median, then it's fine. But if I exclude the median, then I drop the 4 from here and here. So we should really use the method that includes the median when it's even. Now, who's this going to be? See, this is my internet company and they're trying to sell me something and they keep calling me. And I keep telling them, no, everything's fine, I don't want anything new, everything's great, leave me alone. They just won't take a hint. Right, so as I say, Neil, if it's an even number, you should include it. It's only a problem when it's an odd number. Then you have to make it clear what method you're going to use. Okay? Yeah? Okay, so, back to this one. Let's look at the method where we include the median. So here, what would be the upper quartile? Well, we have 1, 2, 3, 4, 5, 6. So it'd be between the third and fourth. 1, 2, 3. So it's between these two. And I think this is your answer, was it, Victor? Yeah. 4.5. And here, 1, 2, 3, 4, 5, 6. 1, 2, 3. It's between the third and the fourth. It's still 1. And the median is still 2.
Which one do they prefer?
Which one do they prefer in the exam? Yes, they do prefer 1. Which one is it that they prefer? I think in the exam, I don't know. I'll have to check the exam. The good news is it doesn't usually happen in the exam. In the exam they usually give you an even number, like 10, so it's not something to think about. Although recently they did do an odd number, and I think they went for exclude. No. I will have to check. I'll check in a little bit for you. Yeah. It doesn't matter, you'll get full marks either way, once you say which method you're going to use. Yeah? Alright, so one method left. I wonder if anyone knows what it might be. So we excluded and included the median. Of what? No, not this. Any other ideas? Any ideas? No, I'll tell you. We'll go for arithmetic method, and this method you exclude and include and take the average of both answers. Yeah, so this one here would be 4.75. It's the average of 5 and 4.5. 4.75.
I think this one really works out.
No, they don't. This is the one I know they don't like because it is the most work, because you have to do both methods. And this one here is still 2. And what's this one going to be? It's still going to be 1. Do you understand the arithmetic method is you add both answers together and divide by 2. This is probably the most accurate method because it uses the other 2 and you take an average. Yeah. But notice that it really doesn't matter too much because, for example, here it's still the same, here it's still the same, and here it's a little different, but not much. And if you have lots and lots and lots of data, these differences become even smaller. So if you had like 21 points, if you had 21 points, then this here, the difference would be very small. So it's not really too important. Okay. And what's the interquartile range for each of these? So for the first method, what is it? Interquartile range? 4. Second method? 3.5. And last method? 3.75. And what's the range for the first method? 8. And the second method? 8. And the last method? 8. So the range is 8 for all of them.
Do they have this one for table?
Say again?
Do they have like this one question like for table data?
What do you mean? I don't follow. What list?
Table data.
Like the tree, the table with the tree.
Tables? Still don't follow.
Like what they were saying. Like the...
Table of this. You mean the example I did?
Yeah.
Oh yeah, you're asking, I understand. Do you have this for tables?
Yeah.
Yes, and that's a different lesson completely. So for this lesson, it's only going to be, I understand, sorry. For this lesson, it's only going to be lists. There's a completely different way to do it when it's a table. In fact, if I draw something for you, maybe this will remind you of what to do when it's a table. Now we'll hear, oh hang on, my pen's gone. So this is Y, this is X, okay. And then we go, some people are remembering this from middle school, and then you go, oh, and then this goes across, and this goes down, and this goes across, and this goes down. Some people have memories of this. Huh? Not line graph, no.
That's what very in high school.
Huh? Yes, that's the one. Yes. Okay. But we don't use that word here. This is like, is it American or... No, in the exam we don't use this word. On the course we use cumulative frequency curve. You know this one? Or CF curve. Yeah. Anyway, that's a completely different lesson for the tables. Okay. Right, so there's some. Actually, I should say, by the way, these questions here, these are very, very common Section A questions. So what they do in the exam, they give you a list, and they ask you usually for the upper quartile, the lower quartile, the median, the range, and the interquartile range. Now you realise once you put the list in order, it's very quick to do all of these. Okay, so the part that takes the time is putting them in order, because in the exam they usually give you a list of 20 numbers. And they won't be pretty numbers as well, they'll be ugly numbers like 42.1 or whatever. So you have to be very careful when you put them in order. But once they're in order, you should easily get it all right, and you should get 5 out of 5 marks. So 5 marks is pretty good for this, for the exam. Okay. Now, if you look at page 12, can you have a look? Really, it's the same type of question, but I want you to practice different methods. So in question 1, I want you to exclude. Number 2, you can see that it's also exclude. Then you have an include, and then an arithmetic, and then the last one is just a more difficult question. Yeah. Yes, all 7 of them. Yeah.
No?
Yeah, there should be time. Ah, yeah. You might even get them all finished now. Okay. If you have a look at the back of page 17, maybe you see some graphs that remind you of your childhood. Page 17. Do these graphs look familiar? Yeah. And then you go across, and then you go down. Yeah. So we'll get Malik. We'll get to that in time. Okay. All right. Try these for a few minutes. They shouldn't cause you much trouble. Can I close this example? Is that yes or no? Well, I'll leave it there for a minute.